说，we can define the energy velocity denoted as VE. VE can be defined as the Poynting vector divided by the energy density. 就是这个电磁能量密度当分母 ，Poynting vector 当分子。那或者是你可以看成这样，就是 S 等于 U 乘上 VE。Here, S is the Poynting vector. And the U is energy density. And so the energy density moves with some kind of velocity. So you multiply the energy density with the velocity to get the energy flow or energy current Poynting vector. Just like in the charge case, you have J equal to rho times V. Here J is the so-called current density. And rho is charge density. And this V is called drift velocity. This is 电荷的漂移速度这漂移速度当然就是说电荷它本身是带质量的东西嘛，那质量的东西它本身可能有热运动或什么，它有其他的速度，但平均之后整体的移动速度就是这个所谓 drift velocity。而这 drift velocity 去乘上 charge density， 就得到 current density。这边情况也是类似你把这个类比成这个的话the Poynting vector is in analogous to the current density, and the energy density is just like the charge density, okay? And so the energy velocity is something just like the drift velocity. But here is for energy and here is for charge. Okay. Now I want to show you that the energy velocity is equivalent to the group velocity. To derive this result, we need to do some calculations from Maxwell's equations. We already know that for plane wave we have K cross E equal to omega mu h, and K cross h is equal to minus omega epsilon E. Okay, we have these two equations. So how to derive the relation between group velocity and energy velocity? We must find some way to reveal the K derivative of omega. Okay. So this means that we must consider to vary the K vector a little bit. Suppose we consider a different K. we change k from k to a different k, say k prime. And the k prime is almost equal to the k vector, but they have a little bit difference. Okay. K plus delta k. Okay. This delta k is an infinitesimal difference from the original k vector. So once we replace k by k prime, we must also replace e by e prime, and replace h by h prime, so that they satisfy the same kind of equation. Okay, and also we may need to consider omega be replaced by omega prime. So omega becomes omega prime equal to omega plus delta omega, and h prime is equal to h plus delta h, and e prime is equal to e plus delta e. This notation delta implies that we are doing something called calculus of variation, 变分. However, you can forget about the terminology calculus of variation. You just treat them as the common differentiation. OK， 好，就是说你把这个 delta 当成 d 就好了啊，就是 you can just treat the delta k as dk, an infinitesimal change of the k vector. Okay, so this means that now I substitute the k with k plus delta k, k plus delta k cross e plus delta e is equal to omega plus delta omega. We cannot change mu. Mu is fixed, but the h in general can be changed. Okay. Then consider delta k, delta e, delta h, delta omega are all be first order infinitesimal quantities. Then we can ignore the second order infinitesimal quantities because 因为微积分就是这样，这就像是什么意思呢？就像微积分比如说我有两个量，一个叫 x， 一个乘 y， 然后我去对它微分，它会得到什么呢？就是它会得到这个 y dx 或者是 x dy， 但是你不会写出一个什么加什么 dx dy 这种东西，不会，没有这东西。原因是什么？在一阶无穷小的时候，相乘的东西去微分就保留到一阶，不会有出现二阶啊。这意思就好像说，我把100万变动100万分之一啊，那一个是应该这么讲应该这么讲，就是说这两个东西我都是变动100万分之一的话，然后我去看它究竟变动相乘究竟变动多少的时候啊，那这个变动是100万分之一嘛，这个变动是100万分之一嘛，但这个就会变成1兆分之一了啊。那我只需要记录到100万分之一，就1兆分之一就不用管它啊。那更何况它是无穷小啊，所以就不会有这个 second order 的无穷小啊。好 ，so to the first order variation, we get something like we just did something like this. So this means that 我去做这个变分运算的时候。So the left-hand side of this equation gives us K cross delta E plus delta K cross E。就这样，没有什么 delta K 或者 delta E 这种东西。然后右边的话呢是 ，so the right hand side gives us delta omega times mu h plus omega mu delta h. Okay. And for the second equation.